The next big step was building up the wings. It's not the next step in the process that RANS lays out, but they also state that you can build all the major structures in any order. And I also wanted to wait till the last possible moment to decide on the avionics and the engine, so I make sure I have the latest and greatest. So I decided my summer build was going to be the wings, so take all summer. And summer is a good time to build these because the fabric, I'm using the Stewart system, and the fabric glue has a minimum working temperature, 65 degrees, so it gets cold here in the winter. When starting any new assembly, the first step is to gather all the components called out in the parts manual, then conduct a detailed and thorough inspection of each part. The next step is to remove any labels with an appropriate solvent and plastic scraper. Most of the time alcohol does the trick, but sometimes acetone is needed for the stubborn ones. And these little acetone pump bottles used by nail technicians are wonderful and make it easy to just get a little solvent on a rag without making a mess. I found them on Amazon in a 2-pack for $8. Definitely worth it. Then after removing the sticker glue or manufacturing ink marks on the stock aluminum, any jagged edges need to be dressed or deburred to eliminate stress risers that may cause a crack, leading to possible failure when in service. The wing ribs are all the same except for the root and tip ribs, which are configured a little differently, but each of them supplied in the kit is slightly bowed from the forming process during manufacture. They're not straight, so each one needs to be straightened using fluting pliers on the flanges. As you can see from its shape, these special forming pliers make narrow and precise crimps or creases in the metal, which essentially shortens the run of the metal so the perpendicular can be formed smoothly around a curve. This process is used on the ribs to remove the bow left over from manufacturing. It doesn't take much effort with the fluting pliers, as the aluminum bends very easily. It's a back and forth process, making a couple little flutes, checking for straightness on the flat bench, then repeating the process until the rib is straight and ready to be installed. There was a lot of work to each of the ribs before I could mount them onto the spars. Here I'm modifying little clips, which were sprayed with zinc chromate primer to prevent corrosion, before being riveted to the leading and trailing end of each rib. The wing spars, compression tubes, and drag braces went together very easily. There were a few measurements to make and fittings to modify, but all of the important assembly holes were pre-drilled from RANS, so there was no need for an alignment fixture. Really, all the big structural parts were just bolted together as they rested on a couple pair of sawhorses. One tip though, I loosely tie wrapped the spars to the sawhorses, so if I bumped it when walking around the tight space, there was no danger of the wing falling off a sawhorse and possibly damaging it. Installing rib number 8 involved assembling and mounting the aileron control bell crank mount. So the rib was test fit, removed, then test fit again multiple times during the process. This bell crank mount is required to take a serious load from the aileron cable tension, so it's a beefy structure with the angle gussets, big bolts, and lots of rivets. In this view, it's also easier to see the tie wraps holding the spars to the sawhorses. Wait! I want to stop the video right here. Do you see the long drill bit I'm using here? There was a hole that I couldn't easily get to with a normal length drill bit. Situations like this can be very frustrating if you don't have the right tool. Luckily, in this case, we have a few specialized aircraft tools that make life much easier. We have really long drill bits and really short ones. Before my kit arrived, I bought a new set of 12-inch bits in the 3 common rivet hole sizes. They're available through the aircraft tool websites, but also Home Depot, who have them for a good price in the complete range of wire sizes. Then there's the really short drill bits, which were made for the pneumatic angle drill motors. Unfortunately, nobody makes a dedicated battery-operated angle drill, so I needed to find another solution, and these 90-degree drill attachments are available to do the trick. I found an individual one on Amazon because I already had the bits, but Aircraft Spruce carries this nice set. Oh, and don't be tempted to buy this type of attachment. They're for the magnetic 1/4-inch hex bits, of which they make drill bits for, but they're too long and don't come in wire sizes. To round out my drill bit collection, along with a set of fractional bits, I also have a complete set of wire size bits, 1 through 60, that surprisingly come in handy all the time. And since I would be drilling many rivet holes, I bought plenty of number 11, 30, and 40 bits, just so there was always a sharp one available. Well, that covers building the structural sections of the wing. Next time I'll talk about installing the fuel tank and mounting the magnetometer and pitot tube and temperature probe.